Now, we have let's go to page 29. Page 29. Now we talk about something new that you may not have heard it in the high school. Something new. And this is called a couple. If you look for the Chinese term, it is this one. And of course, I will say couple. And the couple in mechanics or in statics, that the definition of couple is like this. And two forces, Fa and Fb, and they have the same magnitude. Parallel lines of action. They are not the same line of action. They are parallel. Okay. And opposite senses are said to form a couple. Let me draw the figure. So we have Fa here. Fa. And then we have another FB. FB here. FB is have parallel line of action. Okay, parallel lines of action. And B is going to the right. Okay. They are of same magnitude. They have parallel lines of action, and they have opposite sets of means. Of course, they have an opposite direction. Okay, this form a couple. Now, let's before we talk about the mathematics, let's talk about let's talk about Newton's first law. Newton's first law. Now, here we have Fa, right, and we have Fb. So here. So what's the magnitude of Fa plus Fb? Fa and Fb are in opposite direction. They have the same magnitude. So Fa plus Fb is equal to 0, right? So it has no translation, okay? A translation in plain English usually means this one, okay? But in science or in statics, translation means okay. So if we have Fa and Fb having the same magnitude, but they are of opposite directions, that summation F equal to 0, right? So in theory, it has no translation. But from normal life, that from daily life, you know, if we have two forces going in these two directions, what will happen to this? If we have two forces going like this one, yeah. So the object will rotate, okay? It has rotation, okay? So because Fa and Fb have parallel lines of action. And to say this in a more exact way, that because FA and FB have form a couple. Okay. FA and FB forms a couple. So of course, although we know that FA plus FB, summation FB equals to 0, so it has no translation, but it has rotation because FA and FB have parallel lines of action. I think I put it. This mess is not needed. Okay. So they have parallel lines of action, so it will form a couple and no translation, but it has rotation. Now, it's okay, take your time to write it down. For the next point, we continue with this figure. So and suppose this is point O here. Okay, we calculate the moment of couple about point O. So this is the next step. Say we have point O here. Point O is here. We calculate the moment about point O. So what we have here? How do we do? How do we do this? Of course we can do it like this. And we have this is RA, and this is RB. Logical, right? So nothing wrong here, right? So we calculate MO, then it will be RA cross FA plus RB cross FB. RA cross FA and RB cross FB. Next, what we know is the direction of FB is opposite to direction of FA. So we can say plus FB, and then we change it to minus RA, minus FA. It's okay. Because FA is equal to minus FB. Okay. So of course the lines of action are different, but we can always write it like this, right? We can write like this. And then because these two are both of them across FA, we put it like here, RA minus RB. That's the moment arm, and then this moment arm cross FA. Logical. Sounds okay. Okay. Now let's draw RA minus RB on the figure. Let's draw RA minus RB on the figure. So RA, this is plus RB, and minus RB is here, right? Negative RB is here. So what is RA minus RB? RA minus RB is this one, right? Is it okay? I'm making figure, huh? It's okay. So of course we can say RA minus RB, but of course you can say this is RA with respect to B. The next question is, so we determine this moment arm as RA minus RB or RA with respect to B, then you can write any one of them. So is point O in this equation? Do we have point O here? No. Okay. This one is independent of point O or any reference point. Okay. So although we begin from point O and then we begin from point O, the result is independent of point O or any reference point. You can say we have point Q here, and then you calculate these two points out, you will get the same result. Is that okay? You'll get the same result if you have point P here, point Q here, point R here, point S here. The result will be the same. Okay. Now, so in this case, because it is independent of point O, so in this case for couples we will say it is equal to M. So you don't need to you don't need to write the reference point, okay? You don't need to write the reference point. And is that okay? I will give a revision on these things later today. Okay. Now before we move on, we want to simplify the mathematics further. So we want to make it even simpler. We go back to this figure. Now, so we have RA and RB, right? And then we write the moment arm as RA minus RB. And for this RA minus RB, we can write it in two parts. Let me put this device into we can write I'm sorry, should be in our we can write the moment arm in two parts, right? Of course, from here we have the green one, but we can draw the green one as two blue ones. Okay. The two blue ones are, this one is R parallel and this is R perpendicular. So what do we have? Remember, we are calculating cross product. So cross product is the sine beta. So what's the cross product of our this one and this one? The parallel sine beta is equal to 0. So our parallel, because these two are parallel, so the cross product is equal to 0. Okay. So this one is so if we have write it into our parallel and our perpendicular. So this one, our parallel cross f is equal to 0. And our perpendicular is, what is it? It is the, this is the distance between the two lines of action. Okay, this is the, sorry, this one is this is the distance between the two lines of action, and for calculating the moment arm, that you only need to consider the distance between the two lines of action. Okay. And this one is on page 119, equation 3.46. So especially in 2D, so m is equal to d times f. Of course, in 3D you need to do it in IJK, but in 2D you can do it in d times f. D is the distance between the two lines of action. Is that okay? So if you are okay, and this if you have written down everything on this page, then we can go to the next page. We can go to the next page. So anything? Take your time to write it down, okay? Take your time. Okay. Now, before I move on, I want. Well, because this is quite difficult. Moment. Notation. And the first thing is what we have talked about is moments moment of a force about a point. Now that is what we always know, that this is R cross F. And this one is R, and this one is F. This one is R, and this one is F. And this is 0.8. I think I marked it wrong. I made a mistake here, and A is here. Okay. This one is R, and this one is F. So this is what we always know. R cross F, and the beginning of the whole calculation is your point of reference, which is A here. Okay. And for your, I'm not sure whether you know or you are interested. And what is this thing called? If we write something below the alphabet, what is it called in Chinese? 中文叫什么？记在这里。下面 OK。So what's the English? Subscript, okay? Okay, subscript. So this is what you always know, okay, from high school. So MA is equal to R cross F. And it's okay. So take your time to write it before I go on. Now, anything that I should is it okay? So, and point A should be here, and point R is this one, and F is this one. Okay. Now we have the second thing that we have. Let's say we have a shaft, and we want to talk about moments about a line AB. So MAB, let's say this one is A, and this one is B, and we have a line AB here. So we have MAB is equal to R2 cross F times unit vector of AB. Okay, and F is here. And R2 is here. So in this case, the subscript is the line, okay? So this one is a single On the left, we have a subscript as a single point, and here the subscript is a line. This is also a moment of a force. Now, if we have just talked about couple has two forces, okay? And so for this M is equal to for example, if we have points, suppose we have points, suppose we have points, points B and we have points A here. So we have M is equal to R A with respect to B times cos M. So it has no subscript, okay? Take your time to write this down. Why is it not needed here? Because if we take the result would be the results would be the same if we take the reference point at B, if we take it at A, or if we take O or P or Q. For any points that you take, that the result will be the same. So it is you don't need to write down the subscript. Okay. It's okay. And now, before we finish today's lecture, so let's talk about one more thing. It is so we talk about addition of couples. So if we have, for example, we have a couple. We have two forces F1 and minus F1 acting on these two sides. And we have also F2 and minus F2 acting on these two sides. And F1 and F2 acts on A. This is point A, and minus F1 and minus F2 act on point B. Because these are acting on the same. These two are acting on the same points, so we have we can add them together. And because the moments out is out here. Now, so we can simply add we can simply add M1 plus M2 is equal to M. But first of all, if we talk about forces, we have we have F1 here, right? And we have F2 here. By adding F1 and F2, we have R here, right? And by adding minus F1 and minus F2 here, we have minus R here. So we have actually we can consider a single couple here. That is R and minus R, and we have the small r as the moment arm, right? So this can be done, of course, by using additional forces, but we can also do this by after calculating the moment, and then we calculate the total moment here. Okay, so this is some mathematics, and and this is this can be done. Okay. Now, before and then we go on to the next page for an example. Example 3.6. Of course, you can say we have moments, and of course, if we have moments, and we can add the forces together, but we can add couples together as well. So the answer, we have one structure here. We have a T shape here. We have a T shape here, and determines the couples of a single couple equivalent to the two couples shown. Okay, determine the components of single couple. Because how many couples do we have here? We have one pair of forces, right? We have second pair of forces, so we have two couples. We have two couples. And the question asks us to determine, we make these two couples into an equivalent single couple, okay? So we are changing this from here to this one. It's okay. The question asks us to, of course, we have two couples in the figure. So the question asks us to change these two couples into a single couple. It's okay. Now, so what do we do? We have so we have point denote FC and FE. FC and FE first. We first put FC and FE on the figure. This is FE and this is FC. And then we let so in the calculation we put point D as the point of reference. Okay, we take point D as point of reference. And before we go on that, usually I would check if the resultant force is equal to 0. So this one is 150 Newton. This is also 150 Newton. So resultant force is equal to 0. And this is 100 Newtons, and this is also 100 Newtons. So the resultant force is also equal to 0. So I usually double check the numbers. Okay. Now from here we have two ways of doing things. For method one, we have M is we calculate we take D as point of reference, right? So we calculate the couple here, and then we calculate the couple here, and then we add them together. But let's do it another way. So we first consider these two forces. So we do it using method 2. I don't like this method, so we calculate using method 2. So we first consider. I'm not sure whether I've written down consider is we first consider this pair of forces, okay? So it is 150 Newton, so they have opposite direction, so it forms a couple. So we determine the couple acting on points C and D, and then we have M1 here. And what do we do next? We consider the second couple here. For the second couple, we have 100 Newton to the left and 100 Newton to the right. So we have we calculate the couple on these on points D and E. And afterwards, then we add M1 and M2 together, and so M is equal to minus 69I plus 30J plus 23K Newton. Okay, so this is the answer. Of course, this is not difficult, but it is only how you work on the problem.